Hello, everyone. So, today I'm trying to discuss chapter one, which is Introduction to Vehicles. So, first question is what is a vehicle? So, a vehicle is different with a car, and a vehicle can be in different type. It can be unmanned aerial vehicle, passenger vehicle, or underwater vehicle. The definition for vehicle is a vehicle is a machine that transports people or goods from one location to another location. So that's the definition of a vehicle. So the next question is, how much do we know about our cars? So we have a car, or our parents or family or friends, they have a car, but how much do we know about that car? Is the car, what is the type of the car? Is it an electric car? Is it an automated car? What types of features the car has? So these are the questions that I challenge you to think about when you are looking into your own car. How many gear it has? How many cylinder it has? What's the horsepower? What's the torque of that car? So these are the questions that you might want to think about and you want to answer them. So these are different types of vehicles in general. We can start from micro, and then we go to sedan, CUV, SUV, and so on until trucks and big trucks. There is a website here. You can take a look at types of cars and definition of them in more details. So these are some of the brands for cars. For instance, we know about Ford, Chevrolet, and some others, but there are some specific cars or some specific brands are for specific vehicles. For instance, some companies, they are only designing or developing electric cars like Tesla. Some others, they are only specialized in trucks or van or minivans. So revolution of cars started with the steam engine, and then after that we had gasoline engine, diesel engine, hybrid car, PEM fuel cell car, electric vehicles, and so on. So we have different types of a car as far as engine type. But what is an engine? An engine is a device that transforms energy into mechanical work. So for instance, here you can see that is a human is transforming energy to mechanical work. So that can be an engine. Or we have running water or windmill or steam. One specific type of engine is called internal combustion engine. An internal combustion engine has a long history. For instance, at 1860, linear engine by JJE had the horsepower or power of less than 6 horsepower, and its efficiency was less than 5%. So you might ask, what is horsepower? Horsepower is the measure of engine power and was defined as the energy needed to move 550 pounds 1 foot in 1 second. And you can calculate that using or multiplying torque by 2 pi multiplied with revolution per minute. So there are two videos here that you can take a look at them, and they are discussing horsepower in more details. They are not my own videos, they are YouTube videos, and the sources are provided with the link and information about those videos. There is another video here which you can take a look at it. It's history of internal combustion engine, which is really interesting, and it shows how or what was the history of internal combustion engines. The next event happened at 1876, that the Otto engine by Nicholas Otto has been designed. It was a four-stroke version, and its efficiency was improved, and efficiency of it was 14%. And 1881, two-stroke engine was developed by Dougald uh, Clerk, and then um, On 1889, three-port two-stroke engine was developed by Joseph Day and also son of Bass. 92, diesel engine was developed by Diesel. And 1920 and 1960, there was some steady development in the history of internal combustion engine. But the problem with air pollution has been arised at that specific year. So they started to work on some standards for emissions and emission control of internal combustion engine in 1960. And of course, fuel crisis and more efficiency of internal combustion engine was needed due to the fact that people they started to use internal combustion engine more often, and that started at 1970. And at this point, some of the challenges that we have, and still there are big challenges, the fuel consumption is a challenge, shared mobility, electric engines, how to make it more efficient, how to make it more cost efficient. Those are some of the challenges that we have with any types of vehicles or engines. So let's talk about internal combustion engine quickly, that you can realize what is an internal combustion engine. Internal combustion engine, also is defined as piston engine, is referred to an engine or internal combustion heat engine where a mixture of air and fuel is introduced into the cylinder, compressed, and then it has been ignited. The piston movement is an engine in an engine is covered into rotary motion using connecting rod and a crankshaft. So you can see here the connecting rod and a crankshaft, and that is trying to uh, convert the engine movement into motion using this. So you can see a piston engine here. So you can see here the mixture of air and fuel is get inside your cylinder, and then we have a piston here, and we have inlet valve that's going to be opened at a specific time to let air and fuel get in, and we have an exhaust valve which is going to allow exhaust to go out to exhaust manifold. Of course, we have a piston here, we have a pin, we have a cylinder block, which is shown here, and we have a crank throw here. This distance or this part is important because we can define the torque and power of the engine base using that. You may ask yourself why we are discussing internal combustion engine, or why we are discussing engines or vehicles in general for this specific course, which is connected and autonomous vehicles. The reason we are discussing that is the fact that we have to know what type of vehicle we have, what is the engine type, how the engine works, and other features of the car in order to develop some connected and autonomous features for the car. For instance, if you have an electric engine or you have internal combustion engine, so we need to know that in order to design a specific control for acceleration of the car or a specific braking control algorithm. Let's say, for instance, if it's internal combustion engine, we need a gear and we need to know how to automate those gear shifts with some autonomous algorithms. So that's why we need to know some basics about vehicles, their type, and how they work. So some definitions which are really important, one of them is top dead center is defined when the piston is at its closest position to the cylinder head. So usually if we look at this, somewhere here when the piston is getting to the top is called TDC. And then BDC or ODC is bottom dead center, are defined when the piston is at its further position from the cylinder head. So when the piston is coming down like to the bottom, we call it BDC. Another important information is a crank throw. Crank throw is the distance from the center of crankshaft main journal to the center of a big end. So that's a crank throw. And why crank throw is important? Because using crank throw, we can figure out and calculate piston stroke. So a piston stroke is the piston movement from IDC to ODC, or from TDC to BDC, and is equal to the crank shaft rotation half a revolution, or 180 degrees. So how we can calculate it is going to be L equal to 2R. So that's a piston stroke. I talk about horsepower already, but I put the definition of horsepower here for your convenience. So how internal combustion engine with 4-stroke cycle works. So you can see here a 4-stroke cycle, it has 4 different cycles. One of them is induction, we have compression, we have power, and we have exhaust. In induction, as you can see here, the mixture of air and fuel is going to get into the cylinder. Then it's going to be we are going to have compression, which is going to compress the air and fuel. Then this spark uh, ignition is going to happen, and the ignition is going to power up the compressed of air and fuel, and we are going to have exhaust, and then this inlet valve, the outlet valve is going to be open for the exhaust to go out. Looking at the pressure, like in this plots, you can see that at the beginning we were at TDC, the pressure was almost 0, and then we were going down because it was going down, the piston was going down, so the pressure was getting to the negative, but at the same time we had air and fuel coming in, so that's why the pressure goes to 0 again at BDC. So when the piston is at the bottom, because we have air and fuel here, the pressure goes to BDC, it goes to 0 at BDC. And usually the minimum that we have is 0.3 bar below atmosphere pressure. At compression, we are going to move from BDC to TDC, and the pressure is going to rise to 8, up to 8 and 14 bars, depend on the way it's designed. And then when power or ignition happens, the pressure suddenly goes up 60 bars, and then starts to go down at BDC to 4 bars. And then obviously we're going to have exhaust, and this pressure goes to almost 0 again. So this animation also shows how it works, the 4-cycle for spark ignition engine or petrol engines. So this is cycle of events in a 4-cylinder engine. You see that one of them is doing induction, one of them is doing exhaust, and then the other 2, one of them is doing compression, and one of them is doing power. So that's why most of the vehicles that we have, they are 4 cylinders, because in one cycle of events is going to happen in one time. So the valve timing is also important, but again, it's not the main focus of this class, but I'll discuss it quickly. So at the beginning, what's going to happen, inlet valve is opened. So we are at this point, and then the suction is going to happen all the way here. And then at this point, the inlet valve is going to be closed. Then we are going to have compression, all this black line, and then it gets to TDC, and ignition is going to happen, and then we have power, which is this red line, up to here. And at this point, the exhaust valve will be opened, so exhaust is going to go out, and then exhaust valve is going to be closed again. But you can see here there is an overlap between these two, because at this point both inlet valve and exhaust valve, they are open. So that's the overlap which we are going to have when we design the system or design the engine. This overlap is good, and it has some problem as well. So one of the problem is when this inlet valve is open and exhaust valve is open, we're going to have some mixture of air and fuel going to the exhaust manifold, which is not really like useful as far as emission. So this is another type of engine, petrol engine, is two-stroke cycle petrol engine. So you see that we don't have inlet valve and we don't have outlet valve, but we have a mixture of air and fuel getting in when the piston is at top. So the air and fuel mixture is going to get in, and then when it goes down, this is going to get inside your cylinder. And then of course it's going to be compression, and then it's going to power, and it's going to have this cycle again. So this two-stroke cycle petrol engine, it has less number of working parts because it doesn't have inlet valve, it doesn't have outlet valve, and it's going to be less number of working parts. But there are some disadvantages with this two-stroke cycle petrol engine compared with four-stroke cycle engine. For instance, it's going to be overheated under heavy driving conditions. A proportion of oil will be burned in the cylinder because you saw that this oil and mixture is going to be burned because of the heat. Excessive large amount of residential exhaust gas remaining in the cylinder. So that's one of the other problem, because we don't have enough time for all the exhaust to get out of the cylinder. Inadequate transfer of fresh mixture into the cylinder, because again the timing that this mixture is getting in, it's not enough to have enough mixture inside the cylinder. And the mean effective cylinder pressure in the two-stroke units are far lower than equivalent one for four-stroke. But at the same time, as I mentioned, it runs smoother, fewer working parts, far less maintenance are some of the advantages of two-stroke cycle petrol engines. The next I want to talk about diesel engines or compression ignition. So the only difference between these for four-stroke cycle and an SI engine is the fact that you don't have ignition or spark unit here. We have induction, compression, power, and exhaust. The only difference is that when you have when you want to power, when you do the compression or compress the air and fuel mixture, what's going to happen is this is going to be when it's pressed or pressure is going high, this is going to start to burn by itself because it's heated and it starts to burn. So that's one of the characteristics of diesel fuel. So this is two-stroke cycle diesel engine, but you see that we needed some sort of like a compressor, like air compressor, in order to compress inside pressure a bit more. So there are some advantages and disadvantages between two-stroke and four-stroke diesel. For instance, some of the disadvantages that two-stroke is 40 to 50% more air consumption is necessary in order to work. That's why you have an air compressor. With reduced engine load for a given speed, a two-stroke engine blower will consume more of power developed by the engine. But of course, it runs smoother, twice the power compared with the four-stroke engine. The time available for emptying and filling a cylinder is considerably less in two-stroke compared with four-stroke cycle. So if we want to compare the SI and CI engine in general, petrol engines, the efficiency, thermal efficiency of them is 20 to 30%, but diesel engines are 30 to 40%. Petrol engines, they have shorter stroke and much larger crankshaft speed range, which is going to generate more power in upper speed range. But the diesel engine, it has more pulling torque rather than power in higher speed. As far as reliability, diesel engines are more reliable. As far as pollution, diesel engines are noisier and vibrate more than petrol engine. And as far as safety, of course, diesel fuels are not flammable. That's why they are safer. And cost, diesel engines should be more robust and rugged. That's why they are more expensive than petrol engines. So this shows the components of internal combustion engine. Again, this is for more information for you. You can take a look at it, go through this website, and then you can find all different parts and how they are, what they are doing, and what are their definitions. Okay, so let's talk about vehicle types quickly. So we have gasoline type or gasoline vehicle, which we usually know this type of vehicles very well. We have a fuel tank, we have a fuel filler, we have a combustion engine, we have obviously transmission because they require transmission and gears. We have battery, auxiliary batteries, we have fuel injection system, and then we have also some electronic control unit, which is going to control the ignition and other fuel and air ratio is going to be controlled with that ECM as well. There's a link here. You can take a look at it and have more information about gasoline vehicle. The second type is hybrid electric vehicle. So hybrid electric vehicle is still, it has internal combustion engine and everything is similar. The addition to this is a electric motor or electric traction motor, which is going to help in acceleration of the car at lower speed. So that's why I said we need to know about those things when we design, let's say, some sort of control algorithm for accelerating the car to make it automated. If we are dealing with hybrid electric vehicles, if that acceleration is really high, then automatically the internal combustion engine is going to turn on and it's going to be used, which is not energy efficient. So that's why we need to know how much of acceleration or the pedal percentage we are sending to the vehicle. And when we want to make it drive-by-wire, also we need to know this information about the vehicle. The other thing that we need to know when we are dealing with hybrid electric vehicle is regenerative power or regeneration or electric generator, because this internal combustion engine is going to charge the batteries or battery pack that we have in the car. So we don't have any plug-in to charge them. So this is going to act as a charger and as a generator. The next one is hydrogen fuel cell vehicle, which is basically we have a fuel cell stack. We have an electric motor here. We don't have combustion engine, internal combustion engine anymore, but we have a fuel tank, which is hydrogen, and it's going to be used in order to power the electric motor here. So we have an electric motor, which is bigger. We have transmission, but the transmission is not as complicated as internal combustion engine or conventional vehicles. Because these electric vehicles or electric motors, they have same torque and different speeds, unlike internal combustion engine. So we have a thermal system, we have a DC-DC converter, we have also some power electronic controller here, which is going to feed the needed voltage and current for the electric motor. The next type is plug-in hybrid electric vehicle. So that's again the same as hybrid electric, but this one, the only difference is it's a plug-in type. The next type is all electric vehicle, something like a Tesla, for instance, that it has a battery pack, and then you can also charge the batteries using charge port. We have electric motor, we have again power electronic parts, DC-DC converters, and we have onboard charger. So this is a nice video, which is again a YouTube video. So you can take a click on it and watch this video. This shows how an electric car works in general. So I suggest all of you guys to take a look at this video to learn how electric vehicle works in general. So charging equipment, because when we are dealing with electric vehicle, charging equipments are important. We have three main levels. We have level 1, which is charging 2 to 5 miles of range per 1 hour of charging. That's usually happening in residential areas that they have 120 volt outlet. Level 2 charging is going to charge 10 to 20 miles of range per 1 hour of charging. So this is usually AC level 2 and requires 240 volt or 208 volt, and it can be found in residential applications or also commercial applications. DC fast charging is 60 to 80 miles of range per 20 minutes of charging. This is a DC direct current and requires 208 or 480 volt AC, but it should be three-phase input. These are some different connectors for charging, like vehicle charging ports or connectors. So different companies, they have different ones, or some of them, they have all of them and provides all different connectors. So thank you for your time, and we will discuss the remaining of this chapter in next video.